Hello everyone, my name is Khalid from Group 3. Today, we're gonna talk about the roots on probability demonstrator. As you can see on the content, we will be discussing about the Galton board, or also called the probability demonstrator. The second one is the feature of the Galton board. We will also be having some exercises or solving the problem. And the last part is for the summary. Ang picture na ito ay tinatawag na Galton board or probability demonstrator. It was invented by Francis Galton. Ang board na ito ay mayroong 256 small red balls that are released so they will fall through an array of the hexagon. As you can see on the picture, may mga hexagon ito at yung mga balls ay dito dumadaan papunta sa bin. The board is designed such that when a ball falls on one of the vertex of the hexagon, it will equally likely to fall to the left or to the right. So kapag ang bola ay na-release na sa board, it will either go left or right hanggang sa pababa na ito, and the way left or right is repeated. Kapag ang lahat ng 256 small red balls ay nalagay na sa bin, it will most likely to form a bell shape or called the normal distribution. In the features of the Galton board, there is normal distribution. Gaya ng sinabi ko, it is formed as a bell shape kung saan yung distribution o yung lahat ng balls from the Galton board ay nagkakaroon ng symmetric. Pag sinabi nating symmetric, it means balanced proportion. The second one is called binomial distribution. It is a probability that a ball will likely to fall from any of the bin at the bottom of the Galton board. The third one is the central limit theorem. When you add all the independent random variables, their sum tends toward a normal distribution, which means a binomial distribution approximates a normal distribution. Pag sinabi nating approximate, it means to be exact. So, kapag inad natin lahat ng probability ng binomial distribution, magkakaroon pa rin tayo ng normal distribution. Which means, ang binomial distribution ay hindi siya mag-i-exceed sa normal distribution. There is also one thing called Pascal's triangle. Ang Pascal's triangle ay triangular siya, kung saan yung edges niya sa left and right ay 1 ang nakalagay, gaya ng sa picture. Dito natin malalaman kung ilang roots ba ang tinitake ng ball sa kanyang destination or yung bin sa bottom of the Galton board. So as you can see in the picture, para siyang pattern. So to know those numbers, ina-add natin ang two nearest numbers sa above ng hexagon. For example, on the row 0, there is 1, kung saan yan ang beginning na tinitake ng ball pababa. On the row 1, there is 1 and 1, which means yung pang row 1, isang root lang ang tinitake niya. On the row 2, you can see that there is 1, 2, and 1. Yung 1, yun na yung sa pinakagilid. At saka yung 2, inad natin yung sa taas niya na 1 and 1. So 1 plus 1 equals 2. And then yung pinakagilid sa right ay 1 pa rin. Ang ibig sabihin nun, ang ibig sabihin ng number 2 ay dalawa yung roots na tinitake ng bola. It can either go from the first hexagon and then go to the right, papunta sa hexagon na may number 2. Yun ang first root. The second root is from the first hexagon, which is yung sa row 0, and then going to the left hexagon from row 1 down to the hexagon na may number 2. So, dalawang roots yung iti-take ng bola to go from the middle of the hexagon sa row 2. On the row 3, we have 1, 3, 3, and 1. Yung 1 sa pinakagilid ay isang roots lamang ang iti-take ng ball para makapunta dun sa pinakagilid hanggang pababa. So, sa number 3, we have 2 plus 1. Sa above niya is 3. And then also 3, tapos 1. So, hanggang sa pababa na yung Pascal's triangle, mag-a-add lang siya ng 2 nearest number above the hexagon, and so on, as much as you want. The reason kung bakit nagkakaroon ng normal distribution is because yung sa pinakagitna ng Pascal's triangle ay mapapansin mo na marami siyang number, or it has greatest number compared sa pinaka-edges. So it means yung balls na yon, or yung 256 small red balls ay it will more likely to go to the middle kasi nga marami siyang root compared sa pinakagilid. To understand more about Pascal's triangle, let's try to solve the problems. Number 1, how many roots can a ball take as it travels from A to B, from A to C, from A to D, from A to E, and from A to F? So the answer is, from A to B, there is 1 root. From A to C, there is 4 roots. From A to D, there is 6 roots. From A to E, there is 4 roots. And from A to F, there is 1 root. So to check, let's look back at the Pascal's triangle. In order yung answer from A to B, from A to C, from A to D, from A to E, from A to F, which is 1, 4, 6, 4, 1. So sa Pascal's triangle, ang 1, 4, 6, 4, 1 ay nasa row 4. Question number 2. Allison wishes to walk along the streets from point A to B. How many direct routes without backtracking can she take? So the answer is 35 routes. Para malaman natin kung bakit 35 routes ang answer sa number 2, let's make a simple street diagram instead of looking at the city map. So to simplify, to determine kung bakit 35 routes ang answer sa number 2, we made a simple street diagram. As you can see, it is similar to Pascal's triangle. Kasi nga, Pascal's triangle talaga yung ginawa para malaman na 35 routes ang iti-take ni Allison para makapunta siya sa point B. For the summary of the topic, the Galton board are mainly used for statistics, but we can also use it for finding routes or determining how many routes can we take. So si Francis Galton ay inimbento niya talaga yung Galton board para sa statistics, especially when we are talking about the data in the research. But we use the Galton board for finding routes. There are 4 features of the Galton board mentioned before. Those are normal distribution, binomial distribution, central limit theorem, and the Pascal's triangle. Lastly, we can use the method of the Pascal's triangle to determine how many routes can we take to the specific location. We can use it in real-life situations like in city map, gaya na lamang sa problem solving number 2. And also in chess. For example, we are determining how many routes can we take to go to the top of the chess, and so on. And that's all for the topic on the roots of probability demonstrator.